We're moving on to section 5.3, area of non-right triangles. And this is a derivation of the area equation. And where this is going to come into play is I'm going to use this to prove the law of sines next. So I'm on a Cartesian coordinate system. I have my vertical axis V, my horizontal axis U. And I draw in a non-right triangle, triangle ABC, side C, opposite angle C, side A, opposite angle A, and side B, opposite angle B. If I'm trying to find the sine of this angle, of this right triangle here, if I draw an altitude in here, sine of angle A is going to be equal to the opposite over the hypotenuse. And if I multiply both sides by C, this C will cancel. So H is equal to C sine of A. Everybody good there? And then area of a triangle, area is equal to 1/2 base times height. And this is my base right here, side B. So area of a triangle is going to be 1/2 side B, my base, times my height. But here I've said height is equal to C sine of A. So I'm going to take that value for H and plug it in here. So the area of a triangle is equal to 1/2 base times height, which is C sine of A. And that could work for every one of these angles. So that's actually our next equation for area of a triangle. Area of a triangle is 1/2 BC sine of A. And I remember that it's always, this is a side, this is the angle in between two sides, and this right here is the other side. So this equation only works in a side, angle, side triangle. Okay, so there's three equations for area of a triangle. The first one's going to be 1/2 AB sine of C. This angle is always between these two given sides. Or you could write that equation 1/2 AC sine of B. Or you could write that equation 1/2 BC sine of A. A side B of 9 and an angle C of 14 degrees. So I have triangle ABC. I'm given a side, angle, side. So the area of this triangle is 1/2, one leg, the other leg, sine of the angle in between those two legs, so sine of 14 degrees. So area of this triangle, so area of that triangle is 5.4 units. These are the three equations for area of a triangle. I'm going to take those three equations and set them equal to each other. So I'm going to take 1/2 AB sine of C and set that equal to 1/2 AC sine of B and set that equal to 1/2 BC sine of A. And I could set them all equal to each other because they're all area of the same triangle, right? Just like we did in those example problems. It doesn't really matter which two sides and angle you use as long as that angle is between the two sides. So they're all set to each other. Now I'm going to divide all sides of the equation by ABC. And right here, AB and AB will cancel. Right here, AC and AC will cancel. BC and BC will cancel. They're going to multiply both sides by 2, or all sides by 2. So the halves cancel. And it leaves me with what's called the law of sines. Okay? And that's just sine of any angle over the side opposite it is equal to sine of any other angle over the side opposite it. So The key is in labeling your triangles with capital letters for angles, lowercase for length of sides, and then angle A and side A correspond, angle B and side B correspond, and so forth. So I could write it a lot of ways. I could cross multiply and divide to get C over the sine of C is equal to A over the sine of A. And that's the law of sines. So again, the way I remember it is a side over the sine of the angle opposite it is equal to any other side over the sine of the angle opposite it. One thing I'd just like to reiterate, 3 ways to prove triangles congruent: side, 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 angle, side, and angle, side, angle. With these 2 scenarios right here, if you're given these pieces, you use the law of cosines, and you only want to use the law of sines in an angle, side, angle case. And I'll explain the ambiguous case, which is side, side, angle. That ambiguous case I'll explain next.